In this video, we're going to be taking a look at the introduction to the Pythagorean theorem, and more specifically, we're going to be taking a look at 3.1, discovering the Pythagorean theorem. Okay, so we've learned lots about triangles in other grades, thinking about triangles. Remember, there are 180 degrees in a triangle. So these three triangles down here, make sure you have these definitions written down in your notes. Number one, an acute triangle. Now, in an acute triangle, all three angles are less than 90 degrees. So the term acute means between 0 and 90. Okay, so make sure you have that down. Acute triangle has angles that are less than 90. So here's an example of an acute triangle. An obtuse triangle, that has one angle that is obtuse. And so the term obtuse just means that it's an angle greater than 90. But obviously that angle cannot be anything greater than 180 because that's a straight line. So somewhere between 90 and 180, and this center one is an example of an obtuse. Then the last one would be a right triangle. That's where you have one right angle. Right there's your right angle. Therefore, this is a right triangle. So in this investigation, make sure you can determine which are which and be able to accurately depict acute, obtuse, and right triangles. Now, here we're mostly going to be focusing on right triangles because the Pythagorean theorem only works with right triangles because of their special properties, which we're going to study. Now, the right triangle has its different parts. So draw a right triangle in your notes like I'm doing here. This longest side is always going to be what's called the hypotenuse. All right, and it's always going to be the longest side. These legs, there are two legs there and there, basically your base and height. Okay, those are going to be your two shorter sides. All right, so out of the three sides, the hypotenuse is the longest and your legs are the two shorter sides. Hypotenuse always has to be the longest. Okay, and then down here, can you have a triangle with more than one angle that's 90 degrees? Well, think about it. If a triangle has three angles, all of them do, and each, let's see, a triangle also has 180 degrees in it. If you have one 90 degree angle and you have another 90 degree angle, those add up to 180, right? Which is essentially a straight line. So here's your triangle. Here's one side, here's another side. It makes a straight line. Okay, if you have a triangle that has a really large obtuse angle, right? So let's say here, and then here's your obtuse angle. Then you have this very long line in between them, but you cannot have two angles greater than 90. So now let's jump into 3.1, discovering the Pythagorean theorem. So again, we're looking at squaring off the sides. As you can see in this picture, you're squaring off the sides of the triangles to figure out what the lengths are for each side. All right, so here we have an acute triangle here, an acute triangle here, a right triangle here, and an obtuse triangle right there. And throughout this investigation, we're looking for relationships. Like in the first question, is there a relationship among the areas of the squares drawn and sides of the triangle? What is the relationship? And that's what we're going to be looking at. And is it true for all types of triangle, acute, obtuse, and right? That's what we're going to be focusing. Those are the big questions we're going to try to answer. So first of all, let's go ahead and make a copy of the table below. You can do this in your notes, or you can look at the lab sheet. The lab sheet's available on my website, or you might have been given it in class, but here is the lab sheet, and we're going to go ahead and fill that out. And you are using these triangles up here, right? So 1, 3, and 5, they give you those. 1 is a right, 3 is an acute. So you are doing 1, 3, and 5. So 1, 3, and 5, and then you're creating other ones. So just make another right triangle, make another acute triangle, and make another obtuse triangle on the 2, 4, and 6 sides. One that's different than what's there. Okay? So what you're doing is you're finding the area of the square on side A, the area of square on side B, and the area of square on side C. And then you're finding the lengths of A, B, and C. Remember, it's the length is the square root of the area. So once you find the area, it's pretty easy to find the lengths. Go ahead and do that for triangles 1, 3, and 5, and then come back to the video to see how you did. Okay, so on the first one, the area of the square on side A, so then we are looking at this area right here. And then the area on side B would be that area. The area on side C would be that area. So it's 9, 16, and 25, because the first one is a 3 by 3, so the area would be 9. Next one is a 4 by 4, area would be 16, and so forth. Then we find the square roots of those for the side lengths like we've been doing, and you get 3, 4, and 5. Now let's do that for the next one. So for the next two, you should have the following areas. So the 5, 8, 9 are for these sides. So 5, 8, and 9. And then for the other one, for the last one, the obtuse, 13, 37, and 63. And then the side lengths are the square roots of those. All right, so we have that filled out. And also, I want you to create another right triangle that's different. Okay, so it could be even a little itty bitty right triangle. That would be totally fine. Okay, so there's your itty bitty right triangle. And so you're going to square off, and then square off right there. So that could be an example. Or you could do a bigger one if you wanted to. So come down here and let's do a bigger acute. All right, so here we have our acute, and then you would square off each side there, find those areas, and fill in 2, 4, and 6. So take your time, make your own right triangles, your own acute, and your own obtuse, and see how you did. Now, I'm not going to be doing this, so you'll have to check that on your own. Well, I went ahead and finished out for my right triangle, had areas on those smaller sides of 1 and 1, and then the area of that other one was 2, so my side lengths were 1, 1, square root of 2. And then let's come back to our notes, or rather our books. Make sure we go ahead and find those areas and lengths for all of those triangles. You should have all 6 triangles filled out. So this is all done. You can do that on the lab sheet. That's just fine. Record your results in your table. And then part B, for each triangle, look for a relationship among the areas of the 3 squares on the sides. Make a conjecture about the areas of the squares drawn on the sides of a triangle and the type of triangle. And then 2, test your conjecture by drawing another triangle. So on that piece of paper, draw another triangle to see what happens. So to help answer those questions, like I told you at the beginning of the video, the key was in the idea that right triangles is where we're going to see those patterns. So here I drew a random right triangle with sides 2 by 4. And I don't know what the other side is, but it doesn't matter. But again, it's 2 by 4, so the area of the square off of the 2 side is 4, because the square root of 4 is 2. And I already know that that is my side length, so this is side length 2. And then the square root of 16 is 4, and I can count 1, 2, 3, 4, so that's side length of 4. And this is the square root of 20, or that side length. But that's not important. What's important is, look at this. The sum of the squares of your side lengths, right there, 4 and 16, add up to 20. Okay? So that is the pattern that is true for the Pythagorean theorem. So look down here. Look at your right triangles here. Okay, and again, this is true for right triangles, not for the other ones. If you add the squares of your legs, 9 and 16, it equals the square of your hypotenuse. That's your longest side. So 9 and 16, remember this was 9, this was 16, and this had an area of 25. 9 plus 16 gave us 25. Okay? And also this one, 1 plus 1 is 2, so that works. So that is the property that is true for all right triangles. So if you have a triangle here, and let's say it's just labeled ABC, so let me recopy it to the right. You have a triangle ABC where A and B, those are your legs, and C is the hypotenuse. When you take A and square it, whatever the side length of A is, in this case it's 2, and then take B and square it, the side length of B was 4, so 16, it gives you C squared. So this side length was the square root of 20, square that, and you get 20. So make sure this is written down and labeled as the the Pythagorean theorem. We will be getting more into the Pythagorean theorem and using it to solve different problems, but this is just where this theorem came from and why it works. Again, we'll get more into it, but that is it for 3.1, discovering the Pythagorean theorem.